Hey guys, so today I'm going to be going over how to solve trigonometric substitution problems. In our case, I'm going to be going over specifically ones with values associated with a tangent theta. Alright, so let's start with an example. Right, so the problem is, what is the indefinite integral of 1 over x squared times square root of x squared plus 4 dx? So when you're given these type of problems, it's best to see which formula will you be using. So let's go back and let's go forward. These are the formulas. So we can see that we have a positive x squared. So there's only two values of positive x squared. That's a tangent theta and a secant theta. And we see that we have a positive 4. So that's our a squared. There's only one value with a positive a squared, and that's a tan theta. So we were using the formula x is equal to a tangent of theta. All right. So now that we know what formula we're going to use, what I like to do is I like to just try to simplify the integral. So we need a dx, so we're going to get the derivative of x, and we need x squared, so we're going to square x, right? So let's go. X is equal to a tan theta, so that means a squared is equal to 4, so square root a is equal to 2. So we write it as x is equal to 2 tan theta. So now we need x squared, which is going to be 4 tan squared theta, and now we need dx, which is going to be 2 squared theta. What we're going to do, now we're just going to plug them in to each respected values, which is x squared, and dx, and we get this, right? So now we have this. Let's try to simplify this. What can we do to simplify this? First things first, I like to start off with the square root, so I'm going to take the 4 out of the square root. Well, it's in the square root. I'm going to take the 4 that's multiplying tan squared plus 4 and make a parentheses and make it 4 times tan squared theta plus 1. As you can see, conveniently, this is the same identity that we need that's associated with secant squared. So tan squared theta plus 1 is also equal to secant squared, so I can simplify this further and just write this as 4 times secant squared theta. All right. Now that I have this, let's simplify the square root even further. So let's square root everything, and we will get now 2 secant theta. All right. So once again, we can also simplify this even further. We can cross these two will cross out. Secant theta will cross out at 1 secant theta, and we can pull the 1/4 out. Right? That's what I just did. Actually, I'll just go slower. So the first step I'll do is cross these first twos out and pull the 1/4 out. Right? So I pull the 1/4 out and I cross the first twos out. Now what I'm going to do is, because I have a secant theta over here and I have two secant thetas over here, I'm just going to cross one out and cross one out over here. Now I'm going to be left with secant theta over tangent squared theta. All right. At this point, it's usually best to make the thetas into cosines and sines. So if you can, try to make it a cosine and sine. So as we know from precalculus, secant theta is equal to 1 over cosine theta, and tan squared theta is equal to sine squared over cosine squared theta. So now we have this. Can we simplify this further? Yes, we can. If we divide this, we will cancel one cosine out, and we'll be left with cosine theta over sine squared theta. And this allows us to do u substitution. So it's best to pick u as sine, because if we pick cosine, we can't cancel sine squared out. So we pick u as sine. That would make our d theta du over cosine theta. And this will enable us to cross out cosine theta on top, and now we're left with 1 over u squared, or u to the negative 2 power. We integrate that, and we're left with u over negative 1 divided by negative 1 times 1 over 4, which will give us negative 1 divided by 4u. We insert our u, and we're left with negative 1 divided by 4 sine theta. So this is not the right answer because remember we started off with x's, so we have to end with x's. So how do we change this to x? So remember our problem was x. In the problem we made x equal to 2 tangent theta. We arrange this and we make x divided by 2. This is basically the opposite side and the adjacent side because it's in relation to tangent theta, which is the angle. So x will be the opposite, a will be the adjacent, and if we wanted to find the hypotenuse, we do the Pythagorean theorem, and it will say that our hypotenuse side is x squared plus 4. So since we're dealing with our hypotenuse is the square root of x squared plus 4. Since we're dealing with sine theta in our original solution, we have to change sine theta into x's. So we know that sine theta is going to be opposite of our hypotenuse, so we insert opposite over hypotenuse, and then we just algebraically manipulate our problem, and this will give us negative square root of x squared plus 4 divided by 4x plus c. And that is how you would solve this problem. Problems like these, it's usually best to just review a little bit of pre-calculus and calculus 1, knowing what 1 over secant is, knowing what 1 over secant is, cotangent is, and their respective integrals. Thank you for watching. Please like, comment, subscribe, and have a great day. Thank you.